By now, you probably know the Linux kernel has a GitHub mirror. It is a very fun place, and I highly recommend you check out the pull requests. But why, after all this time, is it just a mirror? Now, 12volts has expressed his general dislike of the GitHub community, the way that people interact with Git on it, the way that people don't really respect commit messages and how they're supposed to be used, but on a technical level. Now, if you want to get rid of GitHub, putting GitLab there instead, go ahead and do so. But why do they use Git directly? Why do they use a mailing list? Why do they use an external bug tracker instead of all this so-called modern developer tooling? I was curious about this myself, and it turns out someone wrote a blog post answering exactly this question all the way back in 2017. Why GitHub can't host the Linux kernel community. This was actually written in response to a comment he got over on Hacker News about another blog post he wrote called Maintainers Don't Scale. And this comment basically boils down to, why don't these dinosaurs use modern developer tooling? Which is a very legitimate question, because the way the kernel does things is very different to most other projects. And if you're a young developer and you've only ever used GitHub or GitLab, and you've only used pull requests on those and issue trackers, not an external bug tracker, you've done all your communication on something like Discord or Matrix, the way that Linux does things is very different. Why though? But it's not like everybody in the kernel is in complete agreement. A few top kernel maintainers vigorously defend mailing lists and patch submissions over something like GitHub pull requests, but at least some folks from the graphics subsystem would love more modern tooling, which would be much easier to script. The problem is, the GitHub doesn't support the way the Linux kernel scales out to a huge number of contributors, and therefore we can't simply move. Not even just a few subsystems, and this isn't about hosting Git data. That part obviously works. That's what they're doing with the mirror. But how pull requests, issues, and forks work on GitHub. Scaling the GitHub way. Git is awesome because everyone can fork and create branches and hack on the code very easily. And eventually, you have something good. Usually you don't, but sometimes you do. And you create a pull request for the main repo and get it reviewed, tested, and merged. And GitHub is awesome because it figured out a UI that makes the complex stuff all nice and easy to discover and learn about, and so makes it a lot simpler for new folks to contribute to a project. You don't need to worry about how branches work and all this stuff. It hides all that stuff, does it magically in the background, which is part of what Linus doesn't really like, because it gets people to just forget about it and just forget the thing that a commit message is supposed to be about, but it does make it easy to work with. Now, this system works really well when a project is new and a project is small. When a project starts to get really big and really old, you might realize a problem. You might realize that certain parts of the codebase have different CI requirements to other parts of the codebase. Maybe you have a bunch of features that you now want to turn into optional plugins and have users be able to install them separately. Maybe you wrote a really great part of your code, but you realize you want to now modularize this and turn this into a separate library that different projects you write can all use. Now you have a problem with everything being in a single repo. But there is obviously a way to solve this. Almost all projects on GitHub do this by splitting up their Monor Repos source tree into lots of different projects, each with its distinct set of functionality, usually that result in a bunch of things that are considered the core, plus piles of plugins and libraries and extensions, all tied together with some kind of plugin or package manager, which in some cases directly fetches stuff from the GitHub repos. You usually see this done in a GitHub organization as well, where all of the different projects are listed as sub-projects. That's great and will fix the problem, but it's not like it doesn't have its own challenges. Your community fragments more than necessary. Most contributors just have the code and repos around that they directly contribute to and ignore everything else. That's great for them, but makes it much less likely that duplicated effort and parallel solutions between different plugins and libraries get noticed and the efforts shared. Any kind of concern, maybe you have shared build tooling or documentation or whatever that doesn't neatly align with your repo split but cuts across the project, becomes painful for the maintainer responsible for that. Basically, you go from all of your community being in this one repo to now it being split across all of these different repos. And this can be resolved by now having another tool where the communication is done there to keep things all together. but the individual repo discussions are now going to be completely split from each other. Some projects suffer a lot more than others. If you have a single maintainer that keeps all of the projects in line, that works well. But when each of the sub-projects have their own maintainers, now you're going to start seeing a problem. And that's exactly what would happen in the case of the kernel. Even once you've noticed the need for it, refactoring and code sharing have more bureaucratic hurdles. First you have to release a new version of the core library, then go through all the plugins and update them, and then maybe you can remove the old code in the shared library. But since everything is massively spread around, you can forget about that last step. Of course, it's not much work to do this, and many projects excel at making this fairly easy, but it is more effort than a simple pull request to the one single monorepo. Then you have the issue of the combinatorial explosion of theoretically supported version mixes becoming unsupportable. As a user, that means you end up having to do the integration testing. As a project, you'll end up with blessed combinations, or at least de facto blessed combinations, because developers just close bug reports with "please upgrade everything first." Again, that means de facto, you have a monorepo, except once more, it's not managed in Git, well, except if you use submodules, and I'm not sure that's considered Git. I'm not sure why he would say that's not considered Git, but yeah. And reorganizing how you split the overall project into sub-projects is a pain, since it means you need to reorganize your Git repositories and how they're split. In a monorepo, shifting around maintainership just amounts to updating the owner or maintainer's files, and if your bots are all good, the new maintainers get auto-tagged automatically. But if your way of scaling means splitting Git repos into disjoint sets, then any reorganization is as painful as the initial step from monorepo to a group of split-up repos. That means your project will be stuck with a bad organizational structure for a long time. So if you want to go and take your plugins repo and now take some of those plugins and bring them back into your main repo and put some of those other plugins in another repo, or move like part of a library into like another sub-library, it's all the exact same thing as going from a monorepo, you just have more blocks to mess around with now. Now, nobody's saying this system can't work, it very clearly can, and there is a lot of projects that do it. But the kernel is a really good example, and probably the biggest, of how it can be done differently. Now, scaling the Linux kernel way. At first glance, the kernel looks like a monorepo, with everything smashed into one place in Linus's main repo, but that's very far from it. So this is where everything eventually ends up. But it's not really a monorepo, it just makes use of Git in a very different way. Almost no one who's using Linux is running the main repo from Linus Torvalds. If they run something upstream-ish, it's probably one of the stable kernels, one of these ones here. But much more likely is they run a kernel from their distro, which usually has additional patches and backports and isn't even hosted on kernel.org. You might have the Ubuntu kernel or the Fedora kernel. Fedora's kernel is mostly upstream. You might have something like the Arch kernel. You might have a custom kernel like the Licorix kernel or the Zen kernel or something else like that. Or you might have a kernel from your hardware vendor, which is what happens over on the Android side and the Chrome OS side, which often have considerable deltas compared to anything hosted in one of the main repositories. Oftentimes, you'll see like 10-year-old LTS kernels on Android phones that are being sold today. No one except Linus himself is developing stuff on top of Linus's repository. Every subsystem, and often even big drivers, have their own Git repositories, with their own mailing list to track submissions and discuss issues completely separate from everyone else. Basically, all of these subsystems are forks of the Linux kernel. They do all of their stuff completely separately from the main kernel. But the way we bring things together to have a fully coherent project is with the Linux Next integration tree, which contains a few hundred Git branches from about as many different repositories. From here, patches can be merged in and eventually make their way into a stable release that you are likely running on your system. Now, all of this madness is managed through the maintainers file and the get maintainers.pl script, which for any given snippet of code can tell you who's the maintainer, who should review this, where the right Git repo is, which mailing list to use, and how and where to report bugs. It's not based strictly on file locations, it also catches code patterns to make sure that cross-subsystem topics like device tree handling or the k-object hierarchy are handled by the right experts. So this is that file, and it is quite extensive. There are a lot of people that work on the kernel, but they're all working in their own separate different repos and just merge it all together in this one place. Since every subsystem and kernel maintainer is basically working on a fork of the kernel, at first, this just looks like a complicated way to fill everyone's disk space with lots of stuff that they don't care about. If you're working on the graphics subsystem, you probably don't care about the networking code or the audio code or the input code or anything else like that. But when you're working on your fork of the kernel, all of that code is still going to be there, and all of that is still going to be taking up disk space. But there's a pile of compounding minor benefits that do add up. It's dead easy to reorganize how you split things into a subproject. Just update the maintainers file, and you're done. It's a bit more work than it really needs to be, since you might need to create a new repo, new mailing list, new Bugzilla, but that's just a UI problem that GitHub solved with this neat little fork button. However, this is something that GitHub doesn't let you easily do. It's really, really easy to reassign discussions on pull requests and issues between subprojects. You simply adjust the CC list on your reply. Similarly, doing cross-subsystem work is much easier to coordinate, since the same pull request can be submitted to multiple subprojects and there's just one overall discussion, since the message IDs, tags used for mailing list threading, are the same for everyone. Despite that, the mails are archived in a pile of different mailing list archives, go through different mailing lists, and land in a few thousand different inboxes, making it easier to discuss topics and code across subprojects, avoids fragmentation, and makes it much easier to spot where code sharing and refactoring would be beneficial. The way that projects on GitHub typically solve this is by just taking a link and then just copying the link elsewhere, or copying the text from an issue into another repo. It's just an extra amount of work, or just doing things with like an external tracker in like a Discord or something. It's a lot of extra work that a mailing list just does naturally, because email is something that you can very easily share between different people. Cross-subsystem work doesn't need any kind of release stance. You simply change the code, which is all in your one single repository. Note that this is strictly more powerful than what a split repo setup allows you. For really invasive refactorings, you can still space out the work over multiple releases, e.g. when there's so many that you can't just change them all at once without causing big coordination pains. A huge benefit of making refactoring and code sharing easier is that you don't have to carry around so much legacy gunk. That's explained at length in the kernel's no stable API nonsense document. And it doesn't prevent you from creating your own experimental editions, which is one of the key benefits of the multi-repo setup. Add your code in your own fork and leave it at that. That's what was initially done with the Rust support in the kernel, for example, and then over time, that has been merged into the kernel. No one ever forces you to push the code back, or to push it into one single repo, or even to the main organization, because there is simply no central repositories. This works really well, maybe too well, as evidenced by the millions of code lines which are out of tree in the various Android hardware vendor repositories. A lot of the code that you're running on your Android device is not in the main kernel tree. It might be open source, it might be available out there if you want to go and run it for yourself, but it's not in the mainline kernel. And this is the key point. This looks like a Monor Repo horror show. Yes and no. At first glance, the Linux kernel looks like a monorepo because it contains everything, and lots of people learn that monorepos are really painful because past a certain size, they just stop scaling. But looking closer, it's very, very far away from a single Git repository. Just looking at the upstream subsystem and driver repositories gives you a few hundred. If you look at the entire ecosystem, including hardware vendors, distributions, other Linux-based OS and individual products, you easily have a few thousand major repositories and many, many more in total, not counting any Git repo that's just for private use by individual contributors. The crucial distinction is that Linux has one single file hierarchy as the shared namespace across everything, but lots and lots of different repos for all different pieces and concerns. It's a mono tree with multiple repositories, not a mono repo. From a purely Git perspective, GitHub could be a part of this equation, but not with the GitHub tooling, not with the issue tracking and pull requests and all of those other little management tools that GitHub has. If GitHub was going to be used in its current state, basically it would have to be used the way it's being used now, as a mirror, as just a repo that is there that you can pull from. You wouldn't actually be doing stuff on GitHub itself. All of the main list and bug tracking and merging would all have to be done in the exact same way they are currently being done. There's also obviously the issue that people like Torvalds just don't particularly like GitHub, but there are things that GitHub can technically change to make it a better option. In short, I have one simple feature request to GitHub. Please support pull requests and issue tracking spanning different repos of a monotree. Simple idea, huge implications. First, it needs to be possible to have multiple forks of the same repo in one organization. Just look at git.kernel.org. There is a lot of repos listed here. Most of these repositories are not personal, and even if you might have different organizations for e.g. different subsystems, requiring an organization for each repo is silly amounts of overkill and just makes access and user management unnecessarily painful. In graphics, for example, we'd have one repo each for the user test suite, the shared user space library, and a common set of tools and scripts used by maintainers and developers, which would work in GitHub. But then we'd have the overall subsystem repo, plus a repository for core subsystem work and additional repositories for each big drivers. These would all be forks, which GitHub doesn't do. And each of these repos has a bunch of branches, at least one for feature work and another one for bug fixes for the current release cycle. Combining all these branches into one repository wouldn't do, since the point of splitting repos is that pull requests and issues are separated too. Related, it needs to be possible to establish the fork relationship after the fact. For new projects who've always been on GitHub, this isn't a big deal, but Linux will be able to move at most a subsystem at a time, and there's already tons of Linux repositories on GitHub which aren't proper GitHub forks of each other. So if you make a fork on GitHub with the fork button, it'll say, this project is a fork of that project. But if you upload a project to GitHub, you can't then say, okay, this project was actually a fork of this other project. That is not something that is possible. Also, pull requests need to be attached to multiple repos at the same time, while keeping one unified downstream discussion. You can already reassign a pull request to a different branch of a repo, but not at multiple repos at the same time. Reassigning pull requests is really important, since new contributors will just create pull requests against what they think is the main repo. Bots can then shuffle those around to all the repos listed in e.g. a maintainer's file for a given set of files and changes a pull request contains. When I chatted with GitHubbers, I originally suggested they'd implement this directly, but I think as long as it's all scriptable, that's better left to individual projects since there's no real standard. Also, the pull request status needs to be different for each repo. One maintainer might close it without merging since they agree that the other system will pull it in, while the other maintainer will merge and close the pull. Another tree might even close the pull request as invalid since it simply doesn't apply to that older version or vendor fork. Even more fun, a pull request might get merged multiple times in each subsystem with a different merge commit. Like pull requests, issues can be relevant for multiple repos, and might even need to be moved around. An example would be a bug that was reported against a distribution kernel's repository after triage is clear it's a driver bug still present in the latest development branch, and hence also relevant for that repo, plus the main upstream branch, and maybe a few more, status again should be separate. Since one push to one repo, the bug fix isn't instantly available in all of them. It might even need additional work to be backported to older kernels or distributions, and some might even decide that it's not worth it and close it as won't fix, even though it's marked as successfully resolved in the relevant subsystem repository. Summary: mono tree, not mono repo. The Linux kernel is not going to move to GitHub, but moving the Linux way of scaling with a mono tree but multiple repos to GitHub as a concept will be really beneficial for all the huge projects already there. It'll give them a new and, in my opinion, more powerful way to handle their unique challenges. The kernel is a really interesting project, right? Like, most projects are not managed with mailing lists and all of this like weird having multiple repos that all get merged back into one repo. Obviously, individual devs have their own private stuff, but you don't have all of these major subsystems that all push back into the one place. I don't know if someone would come up with the idea to do the kernel like this today, but now that it's here, maybe it would be a neat idea if GitHub added a way to do this. I don't know. Would the kernel actually use it? Probably not. There are still the concerns over, GitHub's licensing and now also the AI stuff and all that. But just as a thing that other developers can use in a convenient way, I think that would be really neat. But let me know your thoughts in the comment section down below. Jumped ahead of myself there. If you liked the video, go like the video. And if you really like the video and you want to become one of these amazing people over here, check out the Patreon, subscribe, Liberapay, linked in the description down below. That's going to be it for me, and I like Linux.